Hi guys, this is Miss Howington here at Research Triangle High School. So today we are talking about surface currents. Surface currents are the movements in the top 400 meters of the ocean. They are caused primarily by prevailing winds, but also influenced by landforms and the Coriolis effect. To look at this, the first thing we need to look at is go back and review a little bit our lovely, most favorite diagram ever, the global wind patterns. So we have the global wind patterns that are driven by the uneven heating of the Earth and the Coriolis effect. So we have our hot air rising at the equator because it's received a lot of solar insolation and it's heated up, and then it hits the top of the troposphere and it splits off in both directions. And then eventually cools because the temperature is lower at the top of the troposphere and then sinks back down to Earth and then travels along the surface of the Earth again, heating up. As it travels along the surface of the Earth, that's when we get our prevailing surface winds. They are deflected by the Coriolis effect. In the northern hemisphere, they're deflected to the right of their origin, and in the southern hemisphere, they're deflected to the left of their origin. Back to our global surface currents. So the surface currents form gyres, which are these large circulating patterns that form in each ocean, one in the northern hemisphere, one in the southern hemisphere of each ocean. So we'll look at the North Atlantic gyre in detail. All the other gyres kind of form very similarly. So once we go over the North Atlantic gyre, you'll be on your own to look at the other gyres and to figure them out on your own. So the North Atlantic gyre, we have the North equatorial current flowing along the equator. On the other side of the equator, we have the south equatorial current flowing the same way. As it flows along the equator, it's warming up because we have lots of solar insolation there, and it is forced to turn a little bit north because it hits South America. Once it hits South America, once it turns north, it becomes the Gulf Stream because it's joined by water from the Gulf of Mexico, and that's a warm water current. And if we remember, our surface winds here are blowing from the west, and so that's kind of helping drive our surface current there. The north equatorial current is being driven by the surface winds that are blowing from the east. And so then it gets up to Greenland and is forced to turn, both because there's these little cold water currents coming down like this here, but also because it hits Greenland, and so it turns and becomes the becomes the North Atlantic drift, and it starts to cool down because it's in the polar regions, and so it's not getting as much sunlight anymore. And then hits Europe, and then has to turn south and becomes the Canary Current, and then joins back up again with the North Equatorial Current, and that's how you get the North Atlantic gyre. So again, we have the North Atlantic Current, which is slowly warming as it travels to the west towards South America. It hits South America, is turned north. At that point, it's pretty warm. It turns into the Gulf Stream, which is a warm water current, and it's moving north along North America, the coast of North America. And then the North Atlantic Drift, which is a cooling transitional current. It was warm, now it's getting cold because it doesn't have all that sunlight anymore. And it's moving towards the east, both because of the prevailing winds and because it had to turn because it hit a landform. And then the current hits Europe and turns south and becomes the Canary Current, which is a cold water current which moves south along the coast of Europe and Africa. All right. let's take a look at all of the global surface currents. Take a minute and record these currents on your notes so that you have them all, and observe where the cold water currents are, where the warm water currents are, like on what side of the continent they are, where they're coming from, and that sort of thing, and see if you can come up with a few patterns that you notice about the different warm water and cold water surface currents, and then the transitional cooling and warming currents. So we'll talk about how these surface currents influence the weather patterns and the climates of different areas on the planet. All right, see you in class.